Uh, Good morning, everybody. Myself Swapnil Aswar. I'm here to lead your present seminar on the topic called multiplexer and demultiplexer. Uh, Next 15 minutes, we will talk about what is multiplexer, what is demultiplexer, how it works, and what are the application areas of multiplexer and demultiplexer. Okay, so very first. We'll go through the definition. What is multiplexer? It is also called as the MUX in short. MUX is a digital switch that has multiple input sources and a single output destination. So what it means, it has multiple input, and out of this multiple unit, it selects only one input and supplies to the output. So that's what it is called the digital switch, because all the signals are digital. It is a device that allows the digital information from several sources to be routed onto a single line for transmission for that line to common destination. It is also known as the data selector. The MUX is also known as the data selector. So coming to the block diagram of the multiplexer, how exactly the architecture is. So here we are giving the input at one side, that is source. From source we are taking the input, and this side output we are having destination. So we are having to the power n input lines, and out of that input lines we are selecting only one line so that we can route it to the output transmission. Okay, so how to select this one line out of this to the power n line? So in that case, the selector line performs a very vital role. So this is also called as the select line. So, and again this n, this depend on the how much input signal you have. If we are having to the power n input, so this n equal to the number of select line. If we are having four input, that is we can write it as to the power 2. So here we get n is equal to 2. So for 4 input we need 2 selector line. If we go for 2 to the power 3, that is 8. Here n is equal to 3, then we need 3 selector line, and so on, so that we can get the one output. The select line determines which input is to be connected to the output. So this is very important thing here. So let's take an example. We have multiple sources here, multimedia player for playing the music, MP3 player, a laptop, digital satellite, cable TV, and this is the selector multiplexer, and a single destination is what our surrounding sound system. So what is our aim? We can play the music from all this system. So out of this 4, I have to select one signal only, so that I can transmit it to the sound system, and now I can listen the music. So I can't force all this 4 system to this one at a time. So one by one you can listen. Okay, so how to select this input to connect output? Okay, so there are 4 input, that is 2 to the power 2 input. So n is equal to what we got 2. So these are the 2 selector line. I name it as A and B. Okay, these are the selector line. Now I'm making this as 0 0, both selector line at 0 0. In that case, this my MP3 player will be connected to the output, and the rest of input, that is D1, D2, D3, this will not be connected to the output. This will be disconnected. When I am giving 0 1 as a input to the selector line, that is 0 to the B and 1 to the A, then this D1 will engage with Y, that is with output, and the rest of 3, that is D0, D2 and D3, be disconnected. When I am giving 1 0 to the selector line, that is 1 to the B and 0 to the A, then obviously this D2 will be engaged with the Y, and rest of 3 will be disconnected. Okay, and when I'm giving 1 1 to both selector line, that is to B and A, then this D3 will be coupled with this Y, and this digital TV cable will be giving signal to this, and whatever we are playing music here, we can able to listen from this output surrounding box. So, and the remaining 3 will be disconnected. Okay, in this case. This is how the overall idea. Then coming to the types of mux. This types of multiplexer totally depend on the how much input signal you have, because obviously we are getting only one input, so that doesn't matter. So depending upon the number of input we have, we can classify it as 2-to-1 multiplexer. It has only one selector line. Then coming to the 4-to-1s, it has 2 selector line. It must, because we can write this 4 input as 2 to the power 2. So here we get n is equal to 2. So here we write 2 select line. Okay. Next is 8-to-1 multiplexer. Here we have 8 input, which can be routed to the one input output. So 8 we can write as a 2 to the power 3. So we must have 3 selector line. Next 16-to-1 multiplexer. Here we can write as a 2 to the power 4. So n is equal to 4 we got here. So we must have 4 selector line in this case. That so this classification totally depend on the number of input signal you have. Okay. Up to this, everybody is clear. Okay. I will move to next. This is the logic diagram of 4-to-1 multiplexer. How the logic work for this entire system, because we have to go through it. So this is the block diagram. See, these are the input D0, D1, D2, D3. Okay, these are the 4 input. This is the output Y, and this is, of course, for 4 input we need 2 selector lines. So I choose name it as B and A. Okay, so this is A, and this is B, and this is the output. So now see, these are the AND gate. This one, this is the AND logic. Okay, and these are connected to OR. These are the all input, and these are high at every time. Means we are getting signal continuously from all 4 lines. Okay, so this is at 1, this is 1, all are at 1 position. Okay, all pin are high. This is the A, this is B, this is the inverter. Whatever the input we are giving, we are getting the inverted output. Same thing here. Okay, so starting with 0 0, A0, B0. We'll start A0, B0. We'll go here first, D0. Here we have 1, so this is coming to here. At this point we have 1. Okay, then what next? This is 0. So here 0 going to the inverter. Here we got 1 inverted output. Okay, this is going here. This one is at high, this pin is at high. So here 1, here 1. Then again here V0. Here we got here inverted output, that is 1. So this is going this way. This is also 1. So 1, 1, 1. All pin at high. So obviously the output is high. That is 1. So this is going here 1. Okay, this is activated. So this T0 is going here. Okay, we'll see what happened to this 3. Okay, this is 0. So this is going here. Sorry, this is going this way. 0 0. Same thing is coming here. So this pin is at 0. Okay, this is at 1. So we'll see what happened to this. Okay, this is 0 1 going here. This is 1, so it comes 1 1 0. So it's not on, because it's AND logic, so we are not getting anything here. So this is not this is off. Okay, we'll see what happened to this. This pin is at high, that is 1. Then this one 0 0 goes here, so 0 1 0, and this one 1 1 0 1. This one is also off, nothing comes out. Then D3 it is giving 1, so 1 is coming here. What next? This one 0 is coming here, so 1 0, and this one 0 1 0 0. This is going to be in off state. Okay, so when we are giving selector line 0 0, T0 will pass the signal and it will connect to the output, so and the rest of thing will be disconnected. So whatever the signal we are getting from D0 is selected first by these two lines and then transmitted to the output, to the Y. Means in this case this MP3 player will be connected to the output system, and whatever the music we are playing here, we are able to listen this to the output. Okay. This is about D0. Same logic we can apply here. When we are giving 1 0 1 0, then obviously we will see what happens. Obviously it is going to, in that case this one is going to be 1 1 1. Okay, and this is at high, this is connecting here, and in that case rest of 3, this one and this one is not on, so whatever the signal we are getting from D1, this is connected to the output. Okay, next when we are giving 1 0, then D2 is connected to this and rest of 3, this one and this one is not at high, so whatever the signal coming to D2 is connected to Y. Okay, we are selecting to the output. Okay, next when we are giving 1 1, here 1 1 and in that case this is going to be 1 1 1 and this is going to be in an on state. So and this rest of 3, these are going to be in an off state because all 3 are not high, so obviously these are AND logic, so it's not turning on, so it's a off. And obviously this D3 is selected here by this 2 line, and this signal is coming here and this is connected to Y output. So this is how the logic work for 4 to 1 multiplexer, how to select this input from the n number of input, because see here we are having n input, 4 input, and we are selecting one at a time, and who are the responsible for selecting that input? This selector line. Okay, so this plays a vital role. Okay, by giving the signal to this, you can define which input signal to be converted to the output, means to be routed to the output line. Okay, these are incoming, these are outgoing. Okay, this is clear. Moving to the next, this is a 4 to 1 multiplexer waveform. These are the these are the 4 input waveform. This is the input signal. Okay, this one for D0, this one for D1. Okay, this is for D2, this is for D3. Okay, this is AB, these are the selector line. Okay, this is the signal waveform for selector line 1, that is A, and this one for B. Okay, and this is the output waveform. Okay, this is for to say what is the state of input signal at the inlet. Same thing we are getting at output. See, D0 when it is low, what we are getting at output is also low. Okay, it is not alternating. See, this is high, T1, so output obviously high, 1. Okay, next moving to D2. See, this is high, so obviously this is also high. Okay, moving to next D3. See, this is low, so D3 now output is also low. It means what? Whatever the signal we are having at input, same thing we are giving to the output, just we are selecting one from this number of outputs. Okay, so signal strength will remain constant. That's the main thing here. Coming to the next, that's all about the multiplexer. We'll see what is the demultiplexer next. It is exactly reverse of that what we see in multiplexer. It is also called as the demux. Again, it is a digital switch with a single input source and the multiple output source, and there is multiple destination. It has one input source and a number of output destination. It takes a digital information from one line and distribute it to the given number of output line. Okay. For this reason, DMUX is also known as the data distributor. The logic why we are calling it the data distributor is that because we are having only one input signal and we are distributing it to the number of outputs. So that is, this is why we called it as a data distributor. This is the block diagram of demultiplexer. This is, we are having one input source, and we are having 2 to the power n output. Again, same logic. The how to decide the number of select line n. 2 to the power n. This n is equal to this selector line. Okay. If we are having 4 output, then we can write as a 2 to the power 2. That is, the n is equal to 2. So like this 2 is equal to here number of select line. So this will solve the problem. The select line determines which output the input is to be connected. Again, this plays a very important role. This define this input source where to connect. Okay. So let's take another example. This is the single source. Here we take the desktop. So these are the selector lines. Okay, 2 selector lines, and these are the multiple destination. That is black and white printer, fax machine, color inkjet. Okay, plain plotter. Okay, so we have the 4 output. We can write as a 2 to the power 2. So we got n is equal to 2. So we put 2 selector line here, A and B, and name it as. Okay. So same logic. When we are giving 0 0, the T0 will be connected to this. So the signal will pass to this D0, and this will operate. This will be functional. When we are giving 1 0, then this fax machine will be functional, and the rest will be disconnected. Okay. When we are giving 1 0, then this will be activated. Okay. This will perform the task. And when we are giving 1 1, this pen plotter will be operated, and this will be a ideal condition. Okay. So again, coming to the types of demultiplexer. Again, depending upon the number of output we are having, it is classified into 1 to 2 demultiplexer, 1 to 4 demultiplexer, 1 to 8 demultiplexer, and 1 to 16 demultiplexer. Okay. So for this 1 to 2, we are having one select line because it's 2 to the power 1. Yeah, 1. So n is equal to 1. So this is 1. 1 to 4. So this is 2 to the power 2. So n is equal to 2. So these are 2 selector line. Okay. Then 1 to 8. So we can write this as 2 to the power 3. So n is equal to 3. So these are the 3 selector line. Then 1 to 16. In that case, we can write as this 16 as 2 to the power 4. So n is equal to 4. So we must have 4 selector line. Okay. In this way we can classify demultiplexer. Okay. So what is the logic behind this demultiplexer? We can see that 1 to 4 demultiplexer. Okay. This is the logic diagram. How it select the output to which the input should be connected. Okay. Again, this is the inverter 1 and 2. These are 2 inverter. This is the input which we are having. It is at always giving the signal. So it is at 1 always. These are the AND logic. This one, this one, this one, this one, and these are the output. See, X input. These are the output, and these are the 2 selector line. Okay. These are A, B. We are giving. These are the output. So cross denote which output is connected with the input. Okay. And the rest of things is 0. Means it is not functional. We'll go one by one. First, what I will do, I am giving 0 0, 0 to A, 0 to B. Okay. So let's see what happen. Here 1 X. So this pin will be high 1. So it is 0. So it is going to be 0 here. Again, it will get inverted here. So I will get 1 here. This one is going here through this line, and this pin will be high. Same thing will happen here. 0 will be here. So inverted output I will get here. So this will be high, this will be high. So all 3 pin will be high. So obviously this is an AND logic, so I will get the output. So D0 will be activated, and this X will be coupled with the D0, and rest of 3 will be at off, because see, when I am giving this 0 0, this 0 is going here, so this pin will be at 0, this pin will be at 1, and see, this is going to be 1 here, 1, so 1 1 0, this will be off. You will see this is 1, this is 0, and this is 1, so 1 0 1, this will be off. What happened to this? This is 1, then this is 0, and this also 0. So 0 0 0, 1 0 0, nothing will come out. So this will D1, D2, D3 will be off. So this signal is routed to the D0. Okay, for first logic 0 0. When I am giving 1 0, that is A at 1 and B 0, and what happen? This D1 will be get activated, because see, this 1 is coming here, so this pin will be high, and what happened to this B is 0, so I am getting inverted input here, so it will be 1. I am giving this 1 to here, this pin will be also high, 1, so 1 1. We'll see what happened to this pin. This is 0, inverted output here, 1, and then this to this, so it will happen. This 1 1 1, this will be activated. Okay. Likewise, the sequence goes on, and depending upon this, this will be connected to either of this output. Okay. So this is the logic behind this demultiplexer. Which output signal to be connected to the input signal. Okay, this is the idea. See, when we are giving 0 1, this D1 will be activated. When 1 0, this D2 will get connected with input. When 1 1, D3 will be get connected with the input, and the rest will be disconnected. Okay. Then 1 to 4 demultiplexer waveform. Same thing. This is the input data signal X. You can see this highlighted by red line. This A and B, these are the selector line. Okay, and this D1 to D3, these are the 4 output. Okay, see, when X is high and when D0 is selected, this is also high. Okay, when this is high, and when it is connected to D1, see, this is also high. When X1 is low, and when it is connected to D2, see, this is also at low. Okay, when X is low and connected to D3, it is also low. See, so whatever the value of input at A, whatever, either it may be low or high, same will be we are getting at the output. Okay, no alteration in the waveform at all. Okay, so this is all about the multiplexer and demultiplexer. Now coming to the application of multiplexer, we'll see one by one what is the application of multiplexer, and then we'll go shortly through what is the application of demultiplexer. Okay, first we'll see multiplexer, application of multiplexer. So multiplexer are used in various fields where the multiple data need to be transmitted using a single line. Okay, we are having single line and multiple input we have to carry. So following are some application of multiplexer. Very first is and famous is communication system. We'll see how it works. Communication system is a set of a system that enable the communication line, transmission system, a relay and tributary station, and a communication network. The efficiency of the communication system can be increased considerably using the multiplexer. Okay, the multiplexer allows the process of transmitting the different type of data such as audio, video at the same time using the single transmission line. This is how this communication system work using the multiplexer. Okay, then coming to the second application, that is the telephone network. In telephone network, what happen? Multiple audio signal are integrated on a single line for transmission with the help of multiplexer. Okay, in this way multiple audio signal can be isolated and eventually the desired audio signal reach to the intended recipient. Okay, we are having number of input and the output is only one, so intended recipient we can pass the audio signal so that telephone network can work properly. Then computer memory, we'll see how it works in computer memory. Multiplexer are used to implement the huge amount of memory into the computer. Okay, at the same time reduces the number of copper lines required to connect the memory to the other part of the computer circuit. This is how in computer memory. Okay, how it works in computer memory. Coming to the next, transmission from the computer system of a satellite. We'll see how it works here. The multiplexer can be used for the transmission of a data signal from the computer system of the satellite or a spacecraft to the ground system using the GPS, that is global positioning system. So in this case the multiplexer are used because we are having n number of input and we are routing it to the one output channel. Okay, so that we can carry the signal. Then next, these are all about the application of multiplexer. We will see about what are the different application areas of demultiplexer. Very first is communication system. Same, it is also used in communication. Communication system use the multiplexer to carry the multiple data like audio, video and other form of data using the single line for transmission. This process makes the transmission easier. Okay, the demultiplexer receives the output signal of the multiplexer and convert them back to the original form of the data at the receiving end. Okay, the multiplexer and demultiplexer work together to carry out the process of transmission and reception of the data in the communication system. This is how the combination of multiplexer and demultiplexer are used to carry the data. Okay, so this is also one example. The next one is ALU, that is arithmetic and logic unit. In ALU circuit, the output of ALU can be stored in a multiple register or the storage unit with the help of demultiplexer. Okay, this is how the demultiplexer is used. Okay, the output of ALU is fed as the data input to the demultiplexer. Each output of the demultiplexer is connected to the multiple register which can be stored in the register. Okay, so here we can use the demultiplexer in the ALU. Okay, then next is a serial to parallel converter. We'll see how demultiplexer is used here. In serial to parallel converter, what happens? A serial to parallel converter is used for reconstructing the parallel data from incoming serial data stream. That's why we are using here demultiplexer. In this technique, the serial data from the incoming serial data stream is given to the data input to the demultiplexer. The series of data is given to the demultiplexer at the regular interval. Okay, then what it do? A counter is attached to the control input of the demultiplexer. Okay, what we are doing? We are giving the serial input, then a counter is attached to the demultiplexer. This counter directs the data signal to the output of demultiplexer where this data signal are stored. This counter monitors here the function of demultiplexer. Okay, when all data signals have been stored, the output of the multiplexer can be retrieved and read out in parallel. So this is how it used in serial to parallel converter. Thank you. This is all about the function of the multiplexer, demultiplexer, and their advantage and their application areas. Okay. Thank you for watching this. Thank you.